Hello guys, welcome back to TechBees, and today we are going to solve one of the most frequently asked questions in coding interviews, which is the least common ancestor problem. And before moving forward with the problem, I just want to tell you people that if you haven't subscribed to our channel already, then please do subscribe it and press the bell icon for much more coding interview questions. So guys, in this problem is basically I'm doing it on Hackerrank. So here the problem states that you are given a pointer to the root of the binary search tree and two values v1 and v2. You need to return the lowest common ancestor of v1 and v2 in the binary search tree. So in this tree basically if I consider 4 and 6, here is 4 and 6, and if I want to find the least common ancestor of the two values, then the node 3 is the least common ancestor, and if I consider 1 and 6, then the node 2 is the least common ancestor, because at some point 2 they both meet at 2 when they go up. So in order to solve the problem, I'm going to make use of the three conditions. Basically, the first condition is that for example, if the values v1 and v2 are greater than the root, for example here consider 4 and 6, so 4 and 6 are greater than the root, which is 2. So our least common ancestor, which is 3, it will lie on the right hand side of the root, and if the values v1 and v2 are less than the root, so our least common ancestor will lie on the left hand side. And the third condition will be if one value is less than the root, here in this case it is 1, and the other value is greater than the root, here it is 6 for example, so the least common ancestor will be the root itself. So from the tree we can say LCA of 1 and 6 will be 2. So let's move forward with the coding part. So I'll share the link of the problem in the description box. So here basically we have been given the root value v1 and v2. So let us start with the coding part. So first I'm going to set the base case, which is if root is null, which means if there is no tree, then we must return a null value. That this is actually the base case, and then we take a temporary variable current equal to root. Right. So now we must traverse each and every node in order to find the least common ancestor. So while current is not equal to null, and here we must implement all our three conditions. So the first condition is if both v1 and v2 are smaller than the root, then the least common ancestor is actually at the left hand side. So if current dot data is greater than v1 and current dot data is greater than v2, then current dot left, our current pointer moves towards the left hand side. The second condition is else if current dot data is less than x and current dot data, I'm going to take v1 here, and current dot data is less than v2, then our least common ancestor should be at the right side. So current equal to current dot right. And the third case, if it is 1 if v1 is at the left and v2 is in the right, so we must return the current node as the least common ancestor. So else we must return current, so the current node is the least common ancestor. So here we must also return current. All right, so this is our code, so let us test if it is correct or not. All right, it is processing and we have passed all the test cases. So let us then submit the code if it passes through all the hidden cases. Okay, and yes, we have successfully solved this challenge. It is actually simple, but most people struggle in it because they don't know the approach towards it. So all you have to do is just remember the 3 conditions. For example, here, okay, v1 is 1 and v2 is 7. 1 and 7, least common ancestor is 4. Okay, so that's it. Thank you for watching, and if you like the solution and the approach towards the problem, then do like and subscribe our channel. And the code of this problem I have also provided in the description box. Also the link towards the problem is provided in the description box, so you can solve the problem and practice. Okay, thank you guys, and all the best for the programming interviews in the future. Thank you.